Hey guys, how's it going? Obviously, this is a video where I'm going to go through the Semester 2 exam revision. I've called it a booklet here, but it's probably closer to a practice test sort of a thing. So anyway, we're going to go through these, have a look at how we solve these questions. So the first one, we're asked to complete the table, and we're asked to convert fractions to decimals to percentages, and vice versa in any given sort of order. As you guys may remember, to get from a fraction to a decimal, we need to divide the numerator by the denominator. So in this case, that's going to be 1 divided by 2. And if you split 1 up into 2 pieces, you get 0.5 pieces. And then converting from a decimal to a percentage, we multiply by 100, so we get 50%, okay? So we can do the same thing with that 0.25, that'll give us 20%. By reverse, if we go that way, we're dividing by 100, so that's going to be 0.75. And then coming back to the second row, that 0.25, to get from a decimal to a fraction, we're going to put the 0.25 out of 100. Sorry, let me rephrase that. We're going to take the decimal portion, so the 25, so 25, and put that out of 100. Okay, and now we can simplify that to get it down to a fraction. So straight away I can see that I could divide top and bottom by 25, which would give me 1 out of 4 for my fraction. Then we've got 3 out of 5 as a fraction, so 3 divided by 5 would give it to us as a decimal. Just to show you guys one of the other ways we looked at, just as a reminder, when we've got 3 out of 5, we can go ahead and try work out, well, what does that equal out of 100? Like 5 times what is going to get it to out of 100? And some of you may be watching this and thinking, well, 5 times 20 gets me to 100. And so then I could do the same to the top, 3 times by 20, that would give me 60. And that straight away gives us that the percentage is 60%, right? Because remember, percent is per 100, and this situation over here is 60 per 100. And then once again, 60% as a decimal, we just divide it by 100. Okay, so that's the other way we could do it. You can still do it this dividing way. Either is fun. Okay, and then on the last one, we've got 0.75 as a fraction now. So same as earlier, we're going to put that out of 100. Sorry, just the percentage portion out of 100, and we're going to simplify that. Once again, top and bottom divides by 25 quite nicely. So we're going to get 3, or sorry, yeah, once again, 25. We're going to get 3 out of 4, making this 3 out of 4 there. All right, question 1 done. Question 2, we're asked to evaluate some of these operations. If the denominators are the same with addition or subtraction of fractions, then we are happy and we can just add the numerators together. For this one, 0.85 minus 0.33. If you want to do the working out, you can set it up like this, but for a question like this, it would only be worth 1 mark, so you wouldn't necessarily need to do this, but 5 minus 3 would be 2, 8 minus 3 would be 5, so we've got 0.52. 25% times 80. Look, you may be able to quickly see that that's, a quarter of 80, and so then if we do 1 over 4 times 80, you guys should remember that's the same as saying 80 over 1. And when we multiply fractions, we just multiply the numerators together and the denominators together, so we'd get 80 over 4. And remember, fractions mean divide, right? So 80 divided by 4, well, 20, right? 4 goes into 80 20 times. This one here, 12 over 16 divided by 4. Well, let's set that up so that we've got it as 4 over 1. And then this is where the little KFC motto comes into play. We're going to keep, flip, change. So we're going to keep the first fraction the same. We're going to flip the second fraction. So keeping the first one the same, flipping the second one, and we're going to change the sign from a divide to a multiply. And now we can do 12 times 1 to give me 12. 16 times 4, well, that's going to be, obviously, if it's in the calculator allowed section, you can do it with the calculator. But for our purposes, I'm going to do it like this, right? So we get 64. And now I need to divide top and bottom by a, highest common factor. I don't know if it is the highest, but we're going to start by dividing top and bottom by 4. Because I know for a fact then that that's going to give me 3 over 16. And yes, that is as simple as it goes. Cool. All right, question 2 done. Question 3, we're asked to convert the following fractions to decimals and percentages. All right, let's start with, we'll actually start with part B here, because it's a little bit easier. We can definitely do this one without the calculator. So we've got 11 over 25. To get that to a percentage, right, to a percent, I want to put it out of 100, remember? So I want the goal to be that it becomes 11 out of 25 becomes something out of 100. What did I multiply by to get from 25 to 100? Well, that would be by 4. Whatever we do to the bottom, we do to the top. 11 times 4 would give me 44. So that tells me that we have 44% and we have 0.44 as the decimal. All right, so that's all well and good. I'm just going to give myself some space here for the top one. That's all well and good for that one. For part A, it's a little bit more tricky because 16 doesn't go into 100 nicely. So we are going to have to do 7 divided by 16. Right, and this is, being realistic, this is something that you would probably have a calculator for. But we will just quickly entertain it without a calculator for a second. So how many 16s go into 7? Well, 0. So let's set our decimals up. 16s into 70, that is going to be 4. It goes in 4 times. And we'd have 40, 64, we should have 6. 6 left over. Oh, sorry. Put that in the wrong spot. There. We should have 6 left over, and then 16s into 60 would be 3 times. And we'd have, so 30, 48. We'd have 12 left over. 16s into 120. Yeah, this is definitely, guys, this is definitely one you would have a calculator for, okay? We would have, that would go in 7 times. Oh, put that in the wrong spot, sorry. Go in 7 times. And we'd have 8 left over. And then 16s into 80. Goes in 5 times. So we would have that this is 0.4375, which multiplying that by 100 would be 43.75%. But yeah, definitely a little bit of a trickier one there. And yeah, once again, if you want to check it on your calculator, all you would have to do is that bit there. You just type in 7 divided by 16 to get your decimal, and then obviously multiply it by 100 to get your percent. All right, question 4. We have some adding, subtracting, and multiplying fractions. Hopefully we remember, BIMDAS or BIDMAS or something, some variation of that we've learned in the past. And so we know that we need to do the brackets first, right? So we need to do what's inside the brackets first. So looking at the first one, I got 3 on 4 plus 2 on 5. Well, I need a common denominator here. And I can see, well, 20 is going to be my common denominator, right? 4 and 5, they both go into 20. To get the 3 out of 4 to be out of 20, I'm going to have to multiply the top and bottom by 5. So we'll get 15 out of 20. And to get this other fraction here out of 20, we're going to have to multiply top and bottom by 4. So we get 8. Then for the 8 and 3, our common multiple is going to be 24. So common denominators would be 24. To get the first one to 24, I have to multiply top and bottom by 3. And for the second one, I'd have to multiply top and bottom by 8. So for the first one, we will have 15. And the second one will have 8. Let's start working this out now. So we've got 15 on 20 plus 8 on 20, 23 over 20. Multiplied by 15 minus 8, so 7 over 24. And then we're just multiplying the numerators together. So 23 times 7 would give me 161. And 20 times 24 would give me 480. This would be one that you could check on your calculator if it simplifies. Don't think it will though. No, that is as simple as it goes. So that is our answer. All right. A recipe requires 2/3 of a cup of sugar. If you want to make 1.5 times the recipe, how much sugar is needed? Well, this is telling us that we need to do 2/3. And because it says times, we're going to multiply by 1.5. Now, me personally, I would prefer to be multiplying fractions together. So I'm going to write this as 2/3 times 1.5 over 1. And the 1.5 over 1 thing, that's a little weird, right? Let's get rid of the decimal inside of the fraction here. Let's multiply the top and bottom by 2. And we can see that becomes 3/2. So now I have 2/3 times 3/2, because remember, 1.5 over 1 is equivalent to 3/2, right? So I can, instead of writing that, I can write that. So we got 2/3 times 3/2, so that ends up being 6/6, or 1 cup of sugar. All right, section 2. Find the mean, median, mode, and range of the following numbers. All right, let's start with the mean. If you guys remember, for the mean, we need to add them all together. So 2 plus 3. Actually, let's use our notation. If you guys remember from that assignment, we use X bar to represent the mean. That's going to be 2 plus 3 plus 3 plus 5 plus 7 plus 8, divided by however many there are. And there's 1, 2, 3, 4, 5, 6. So we're going to divide that by 6, which will give us on the top 2 plus 3 plus 3 plus 5 plus 7 plus 8. So give me 28 divided by 6, which would be 4.67 if you round it to 2 decimal places. Cool. All right, mean done. Now it's time for, let's do the median. Luckily for us, the numbers are already in order, but remember, if they weren't already in order, for the median, we need to put them in order. All right, but they are already in order, so we just need to cross out from either side. And you can see we're left with 2 numbers in the middle here, right? I've crossed an even amount out on either side. When that happens, if you guys remember, we need to add these numbers together. Let's make sure it's clear what I'm working out here. I'm working out the median. We need to add these 2 numbers together and divide them by 2 to find the halfway point between them, right? Which is going to be 8 divided by 2, so 4. And I know this is probably an easy one, and you could have seen, well, straight away that halfway between those 2 numbers is 4. But if it was a harder one, that is how we do it. So my median is 4. All right, next up, we've got the mode, which is the most common number. You guys should be able to see that 3 is the only one that occurs twice. So my mode is going to be 3. And then we've got the range, which is going to be the highest number minus the lowest, which is going to be 8 minus 2, which is going to be 6. All right, all done. A bag contains 3 red. It can be helpful to draw these questions sometimes. So 3 red, 2 blue, and 5 green. 1, 2, 3, 4, 5 marbles. List the sample space. Well, if we're going to pull a marble out, I could get red, I could get blue, and I could get green. So that's my sample space. Probability of drawing a blue marble. Well, that is the probability of the number of blue marbles, so 2, out of how many total marbles there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 out of 10, which would simplify to 1 out of 5. Okay. And this particular question doesn't say, but for probability, we could give our answer as a fraction, decimal, or percentage, right? So you would have been just as valid if you had said 20% or 0.2. All right. Construct a dot plot for the following data. Now, it would have been nice if they gave us an actual number line for this. So I'm going to get my ruler out. I'm going to get my ruler out, and I'm going to draw a line. I can see I've got red, blue, green. I've only got 3 colors here, so I don't need too many sort of increments. Cool. I've probably actually made that a little bit too long. All right. So we're going to have red, blue, and green. And if we go through, we can see that red appears 1, 2, 3 times. So for red, I'm going to put 1, 2, 3 dots. Then for green, I can see that pops up 1, 2, 3 times as well. So for green, we're going to put 1, 2, 3 dots as well. And ideally, if you've got 3 dots in 2 piles, they should be the same height. Okay. Now for blue, I've got 1, 2, 3, 4. We've got 4 times that it pops up. So 1, 2, 3, 4. And you can see that that's a bit higher now than the other 2, as it should be. Cool. The scores of 10 students in a test are as given. And we're asked once again to find the mean, median, mode, and range. Let's see, mean. It's going to be x bar, which is going to be equal to, I'm not going to write them out this time, I'm just going to add them together. So 45 plus 67 plus 89 plus 45 plus 90 plus 67 plus 88 plus 90 plus 45 plus 67. So altogether that would give me 693. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers here. So that's going to give me a mean of 69.3. For the median, they have not put it in order for us this time, so we're going to have to put this in order. Let's have a look. What's the smallest number here? I believe it's 45. Yep, so 45 happens 3 times, so we'll write 45 out 3 times. Next smallest, it's going to be 67, so we'll get rid of the 3 67s. Then we've got 88, 89, and 90s. All right, and then we're going to cross out from either side. So cross, 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 cross. Once again, we're left with 2 in the middle, but it's the same number. So 67, that's our median. All right. Now, if we were to do the mode, you would have noticed that there was 3 45s, 3 67s, and 2 90s. So obviously there's more 45s and 67s. If you remember, we can have multiple modes. So 45 and 67 would be the mode of our data here. Just excuse me for 1 sec, guys. I'm just gonna quickly have a drink of water before I do the range. All right, for the range, we're doing the highest number minus the lowest number. In this case, the highest number was 90, the lowest was 45, so our range is 45. Done. All right. We've got a spinner with 5 equal sections, which I will struggle to draw for you guys. 1, 2, 3, 4, 5. So I know they're not even, but there's 5 sections there. We've got a red section. We've got a blue section. We've got a green section. We've got a yellow section. Ooh, what did I do there? We've got a yellow section and we've got a purple section. What is the probability of getting red, blue, or yellow? So once again, proper notation, probability of red, blue, or yellow. Well, that's 3 different outcomes on that spinner. 3 different outcomes out of the 5 possible outcomes. So that's my probability. Once again, if you had said, 60% or 0.6, you would have been just as accurate, but we don't need to say that as well unless the question asks for it, okay? All right, explain what the disadvantages and advantages are of median as a measure of center. Okay, well, it is the advantage. It is less affected by outliers. A disadvantage, you guys might come up with some different ones, but I might say that with smaller sample spaces, which just means small pots of data. So for example, like this one up here, question 5, we didn't really have that much data, did we? So with smaller sample spaces, it is less representative. So it's just not as good of a representation of the center when there's not too much data. But that kind of goes for most measures of center, to be honest. The advantages and disadvantages of the mean. Well, for the disadvantage, it is heavily affected. I might be using the wrong affected here, actually. By outliers. And the advantage, I've used opposite colors here, sorry guys. The advantage is that it often when people say the term average, they are just straight up talking about the mean, right? Because it is accounting for all the data points, assuming that every bit of data is accurate. Like if you do have outliers, but the outliers are accurate, it does represent the true center, but then it's, in real life situations, it can be a bit interpretive, like whether that's a true reflection of where the middle person would be or something like that. So it does get a little bit tricky, but definitely the key disadvantage here is that it's heavily affected by outliers. Okay. Algebra. Question 11. Write an algebraic expression for 5 bags of apples and 3 boxes of oranges. Well, A and O. Actually, O is a terrible pronumeral to use. For oranges, I'm going to use the letter R. Where they each have the same amount. So if we were writing the total amount of apples and oranges we'd have 5A plus 3R. Okay. Simplify these expressions. A added together 3 times, that would be 3A. A times B times B, that's A squared times B squared, which we can just write as A squared B squared. 2A times 3B, we multiply the coefficients together first, so 2 times 3 is 6. And then we mash those pronumerals together. So 6AB, A plus B plus A plus B. Well, I've got 2 A's there, and I've got 2 B's. Cool. When x equals 4, is 5x equals 20 true? So 5x equals 20. If we replace that x with a 4, it works, right? 5 times 4 is 20. That's exactly what we want. For this one here, we got AB plus 4 equaling 10, okay? And A and B are 2 and 3, so 2 times 3 plus 4 equals 10. Well, that's going to be 6 plus 4. Does 6 plus 4 equal 10? Absolutely, it does. That one is also true. Simplify the expression. 3A plus 4B minus 2A plus 5B minus B. I can see that I've got some like terms here, 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 and here. So if we take 3A minus 2A first, and then we put the other things down, altogether that is going to end up as 1A, or just A, and then we've got 4B plus 5B, so 9B minus 1B plus 8B. Write an expression for the area of a rectangle. All right, let's draw this rectangle. All right, rectangle with a length of 2x and a width of 8. Length of 2x and a width of 8. If you guys remember, the area of a rectangle is length times width. So in this case, we're going to have 8 times 2x. So 16x would be for the area of that rectangle. And I mean, look, I know it says expression, and I've got an equal sign here. So technically my answer is just 16x on its own, I suppose. All right, section 4. I believe this is the last section. Also the most difficult one, though. All right. A class has 30 students, 18 are girls. What percentage of them are girls? 18 out of 30. If we do 18 divided by 30 on the calculator, we get 0.6, which is 60%. Survey shows the heights of 5 students in centimeters as following. So we've got, we're going to find the mean, median, and mode. So we've got a mean that's going to be adding those together. 150 plus 155 plus 160 plus 145 plus 150. 760 divided by 1, 2, 3, 4, 5. 152 for the mean. For the median, well, we need these in order. So the smallest number here is 145. Then we got 2 150s. Then we got a 155. And then we've got a 160. Cool. Cancelling out from either side gives us 150 as my median. For the mode, the most common number there is 150. Answering part B, which average best represents the data, they are all very similar numbers. Let's be real, 150, 150, 152. But because it's such a small data set and there are no outliers, I'm going to say the mean best represents the data. But you could justify any of them for this particular data set. Use substitution to evaluate the values of these things here. We're given that A equals 2, B equals 3, C equals 4, and E equals 5. So for this first one, instead of A, we're going to put a 2. Instead of B, we're going to put a 3. Instead of C, we'll put a 4. And instead of E, we'll put a 5. BIMDAS, once again, tells me that I do the 6 first. And I've got plus 4 minus 5. So that'll be 10 minus 5. So I will get 5 as my answer for that one. This one here, we've got, remember, when the A and the B are sitting next to each other like that, it means A times B. So we're going to have 2 times 3 once again, plus 2 times 4. Remember, I'm just replacing it with these numbers here. And minus 5. Doing my BOMDAS or BIMDAS. First, I've got 6 plus 8 minus 5, which will be 14 minus 5, which will be 9. And that is, we're done. Expression 1, expression 2, that is the question. Store offers a 15% discount on all items. If the jacket originally cost $120, what is the discounted price? Well, I'm starting with $120. And if I'm taking, and that, that would be like 100% of the price, right? Now, if I'm taking 15% off, I want to find, well, what's 85% of the price? And the key word I keep saying is of, which means multiply. So essentially I'm doing 120 times 85%, throwing that in the calculator. If you know how to put the percent symbol in, then you can do it exactly like that, or we can convert it to a decimal and throw that in the calculator. And so we would end up with $102. There are quite a few ways you could have done this one. You could have just done 120 times 15%, right? Because that's what we're removing, times the 15%, and you would have got, obviously that's the same as 0.15, and you would have got 18, and then if you did 120 minus 18, because we're taking 15% off, you would have also got 102, okay? And there's, look, to be honest, there's other ways again, but either way will work. Just do whatever, do it whichever way makes the most sense to you. Students scored 75%, 82%, and 91% in 3 subjects. What is the average score? 75 plus 82 plus 91. If they just say average, I'm going to assume they mean the mean score. So we're going to have 75 plus 82 plus 91, which will be 248. Make sure I'm showing my working out. Divide that by 3, gives me 82.67. And these are percentages, so 82.67%. All right, we've got to evaluate some more expressions. So once again, using the values down here, AB is going to be equal to 2 times 3 plus 2 times 4 minus 5. This looks really familiar, actually. Is this the same question? Yeah, it is. Oh, well, you get to practice it twice. We've got 6 plus 8 minus 5, which once again was 14 minus 5, which same answer is 9. This one here, though, does look a bit different. So we got 2, and remember when it's sitting outside of brackets, it means multiply. So 2 outside of 3 plus 4 minus 5. Once again, BIMDAS, we're going to do the stuff in the brackets first. So 3 plus 4 would be 7, minus 5 would be 2. So we've got 2 times 2. Now that we've completed everything in those brackets, they're actually doing nothing. So we can get rid of them. 2 times 2 gives me 4. All right, I am going to have to call it there, guys. I know I've still got 2 questions left, but I've got a class to teach. I will jump back in a second. All right, and we are back now. All right, so we've got 8 teammates stopping at a hamburger shop after training. And the gist of this question is that we have to write an algebraic expression. So as we read through it, I'm just going to assign some variables. If they bought 2 family-sized fries, I'm going to say that, a set of fries is represented by the letter F. 3 burgers, well, burgers can be the letter B. A box of nuggets, we'll give nuggets the letter N. And 8 bottles of Powerade, the letter P. And they're going to split the bill evenly. Remember, there are 8 of these guys, 8 teammates. So altogether, how much is that going to cost per person? Let's have a look. We got 2 family-sized fries, so 2F. And then we've got 3 burgers, so 3B. We got 1 box of nuggets, so I'm just going to represent that with a singular N. And 8 Powerade bottles, so that would be the total cost for everyone. In order to split it up between 8 people, I'm going to divide all of that by 8, right? And so that's how that one's going to look. Technically, you could have also written out your answer with some brackets. So if we did it more like this, I would also be able to pay that. Okay. All right, last one. The following test scores out of 100% were recorded on a Hass test. We're asked to create a graph that effectively shows this data and find the average result. So let's start with the, creating a graph bit. My preference for something like this is probably going to be a stem and leaf plot. So I can see the smallest value is 21. And the largest value is 99. So I'm going to start my stem and leaf plot at 2. And we're going to make our way up to 9. go. Hang on, guys. Just make that a little bit. Give myself a little bit more space here. Stem and leaf. So yeah, so 2, 3, 4, 5, 6, 7, 8, 9. And if we are starting with that 21, we're going to put a 1 in the leaf. Do I have any 30s? I've got a 36. So we've done the 21. We've got a 36 and that's it. So we'll put a 6 for 3s. Have I got any 40s? I've got a 44. So we'll put a 4 in for the 44s. Have I got any 50s? I've got a 53. So we'll put a 3 in for the 50s. For the 60s, I've got a lot here. So what's the smallest one? Looks like it's going to be 66. Yep, sure is. So 66, and then we've got 1, 2, 3 67s. So 7, 7, 7. And then for the 70s, we've got a 72. So I'm going to put a 2 there. For the 80s, we've got a couple. We got 88 and 89. So we'll put an 8 and then a 9. And for the 90s, we've got 90 and then 99. So a 0 and then a 9. Perfect. And then we're asked to find the average result too. So when I ask for the average like that, I'm assuming that they want mean. So same as before, we're going to have to add all these numbers together. So I'll just rub that out so that we can see what we're doing here. And sorry, since teaching that class, I have put my calculator away. So I'm going to get that back out. 67 plus 21 plus 66 plus 67 plus 67 plus 89 plus 88 plus 99 plus 36 plus 44 plus 53 plus 90 plus 72. So adding all of them up, we would get 859, and there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers there all together. Dividing by 13, we get 66.1, roughly anyway. A mean of approximately 66.1. You don't need to know this, but if we do squiggly equal signs like that, it means approximately because we've rounded it. All right, guys, that is the practice test. Let me know if you have any other questions when I see you in class next.